So I thought I'd go ahead and throw in my commentary and analysis of Wednesday's test flight, high altitude test flight for Starship.
T-minus 1 minute.
Basically, Starship, if you may or may not know, is going to be the second stage of the Starship system. This is the second stage here. This is 50 meters tall and 9 meters diameter. So actually you're looking at about 160 feet here. That's like a 15-story building. It's very big. It's kind of hard to judge the size from what you're looking at here. It's equipped with 3 Raptor engines made by SpaceX. Those currently are about $2 million a piece to produce. They're bringing the cost down through mass production. Elon says they expect the cost to drop down to about $200,000.
10, 8, 7, 6, 5, 4, 3, 2, 1, 0.
Now keep in mind, this is the second stage. This is not intended to launch from the ground like this. This is using 3 sea-level engines. These engines are really only going to be used for landing. So as it's descending, you see it's going up pretty slow. This thing is huge and it's very heavy. It's only partially filled with fuel. You can see the line of frost around the tank. It's only a thin line. That is there are 2 tanks. There's a methane tank and a liquid oxygen tank. Neither one of them is very full right now. So again, these engines are really only going to be used for landing. The final version will have 3 vacuum optimized engines that will be placed around this center cluster of 3 sea-level engines. So this is going to ride on top of the Super Heavy booster. So it's going to be a much larger system. The Super Heavy booster is going to have 31 of these sea-level engines, the same engines you're seeing here. So the Raptor engine has set the world record for the highest chamber pressure of any rocket engine design. Well over 300 bar of pressure. They're shooting for 350 bar by the time. Okay, now what you see here is you saw the engines gimbal to correct the attitude, and then they shut one engine down. This was intentional. They actually gimbaled so they can tilt the Starship so that it's not straight up and down, because now the thrust is offset. It's off center, and so in order to compensate for having the thrust off center, they have to go up with a little bit of a tilt so that the center mass is still directly over the thrust vector. So you can see it kind of angle in its flight right now. That's intentional, and you're going to see in a short period of time, you're going to see the other engine, the one in the back, that's going to shut down as well, and you'll just have the one engine. You'll see them gimbal, the engine gimbal to correct for the change in thrust vector. The target altitude was 12.5 kilometers. I do believe they did achieve that altitude. There they go. And second engine shut down. Now you can see it's really tilted. They intentionally launched this over the Gulf of Mexico, so that if anything went wrong, they would abort into the Gulf to protect any people on the land, prevent any damage that may occur, or putting anyone in danger. Now, what it's about to do here has never been done before. So you see that the Starship has 4 little wing-like flaps. Those are for its descent. So this is going to be a hypersonic vehicle. It's going to be into orbit. So you're looking at orbital speeds, orbital velocities of 25,000 kilometers per hour. That's extremely fast. So to re-enter the atmosphere, it's going to have a heat shield on the windward side, but then it's going to use the atmospheric drag in order to slow itself down, and then it's going to just basically fall, and like it's doing now, it's falling down, and it's using the flaps in the exact same way that a skydiver uses his arms and legs to control his descent and steer himself and keep himself horizontal. That's exactly what Starship is doing here, and this was the first test of this. This was like the primary goal of this test, was to test this descent method, and as you can see, it worked perfect. It was actually, with a very high level of precision, was able to steer itself down back to the landing site. Now, I'm not sure as far as bleeding off velocity. Hopefully that those results were acceptable. I mean, I think Elon Musk has tweeted that, you know, it was a very successful success despite the ending here. If you haven't seen the ending, stick around. It's going to be exciting. But now, since those tanks are empty, it's in a zero-G situation right now where it's falling, the fuel inside those tanks is sloshing around, and actually it's weightless inside the tanks. So for the engines to draw fuel from those tanks, it's going to suck in a lot of air, and that's no good. So there are secondary tanks that are spherical, and they're smaller, and they're inside. Those are the header tanks. One is up in the nose cone in the very tip, and then the other one is actually inside the primary tank on the lower third of the vehicle. So the engine actually switches over. There you go. I'm going to talk about what happened here. I'm going to have to go back a little bit. Notice the green flame and the hard landing. I'm going to go ahead and pause this. So you notice in this diagram, which is actually serial number 5, but it's very similar to serial number 8, you'll see down at the bottom, you see the center cluster of engines. Those are the sea-level engines, and then around the outside, you see the larger engines. Well, it's the same engine, but it has a larger nozzle. That is the vacuum-optimized engine that is not on this test vehicle. If you look at the tanks, you see the green tank, and then you see a smaller circular tank. That's the header tank. That is so normally on these the ascent, the engines draw from the outer tank, and then for landing, the engines switch over and draw fuel from the smaller tank, which remains pressurized, so that we avoid the problems of the fuel being in there under lower pressure and 0G, where you're going to draw in air into the turbo pumps, which is catastrophic. And then up in the very top, the blue, in the very tip of the nose cone, you have the other header tank. So those are the two tanks that was another part of this test, was to test the switching over from drawing fuel from the outer tanks to drawing fuel from the header tanks. Now, they did do this test in a static fire on the ground, and they did it several times, and did it successfully, but this was the first time they did it in flight, and that was key. Now, you saw the landing, you saw what happened. Let's talk about that. Basically, what we saw here was the fuel level, or the fuel pressure, dropped in those header tanks. Now, Why that happened, I don't know. I think it's probably an error or a problem with the autogenous pressurization system. Now, normally rockets, as you burn the fuel, the pressure in the tank drops because the volume is dropping. As the volume of a tank drops, the pressure drops. So to compensate for that, either they're going to use helium or nitrogen to pump into the tank to that's an inert gas that pumps in there to keep the pressure up, or in this case we don't want to use that because we can't get helium on Mars. So what they do is they use autogenous pressurization, where a portion of the fuel is siphoned off and then heated and then converted into a gas, and that gas is injected into the liquid tank, which increases the pressure. So that's what went wrong. We saw as it's doing its landing burn, as this part here, you see the engines are lit and highly gimbaled over. Now this shows all three engines. This was speculative, done by a fan. This is not released by SpaceX, but it lit two engines and gimbaled over, just like in this picture. But what happened was, as they lost pressure, you see that the gas turns green, the flame turns green. So what happened there? One of the engines, if you look in slow motion, you see one of the engines flamed out entirely, leaving just the other one, and the exhaust gases were green. That's a bad sign. What happened is, because of the pressure loss, one engine shut down. The other engine began to burn very oxygen rich, so not enough methane, too much oxygen, and that increased the combustion temperature beyond the limits. And the green you see is actually caused by the melting of copper and having copper thrown into the combustion chamber and burned. So basically the engine's eating itself, consuming and combusting itself. So the engine is basically dead. Probably bits of the turbo pump are in the combustion chamber, being liquefied and vaporized. And so with that loss of thrust from the engine shutdown, and then the other engine not performing nominally, it was not able to slow the descent as much as it should have, and we ended up with a hard landing on the ground. So the good news is, of course, no one was hurt. Starhopper, you can see him on the right there. Got good video of it. Starhopper has video equipment and everything on that sort of thing on him, but he got to see his big brother come down and conclude a very spectacular and successful test despite the ending. I think serial number 9 is pretty much ready to go, and it's going to be brought out there as soon as possible. They do have to make some repairs to the landing pad. Those are going to be quick, and we're going to see serial number 9 fly very soon. I think they know what went wrong, and again, I think it's autogenous pressurization system, but they know what went wrong, and I think they're going to it's probably just a software fix, but it could be something with a little more serious, perhaps placement of the gas generators, or maybe there was a gas generator failure, and it's something that maybe they just need to throw some more sensors in there, or whatever. We'll find out soon. I think they'll let us know as soon as they know something. They'll let us know, hopefully. But stay tuned for serial number 9. It's going to be another great show, and hopefully, I think, a successful landing. I think they can pull it off. This was much more successful than they were intending it to be or expecting it to be. So I think we'll see a completely successful flight with serial number 9. Anyway, I hope you enjoyed this video and hopefully learned a few things. Please leave a comment, like and share this video. Let me know what you think. When do you think serial number 9 is going to fly? And do you think it'll be successful? What are your expectations? Let us know in the comments. Thanks, and I will see you on the next video.